To find the missing number in an array of integers from 1 to n, where the array has n-1 elements, sum formula method. Calculate the expected sum of numbers from 1 to n using the formula, sum equals multiply n by n plus 1, divided by 2. Calculate the actual sum of the array. The difference between the expected sum and the actual sum gives the missing number. To count the trailing zeros in the factorial of a number n, you need to understand that trailing zeros are created by factors of 10, which result from multiplying 2 and 5. In a factorial, there are always more factors of 2 than factors of 5, so the number of trailing zeros is determined by the number of times 5 appears as a factor. Algorithm to count trailing zeros. Count the factors of 5, divide n by 5, then by 25, then by 125, and so on. For each division, keep adding the quotient to the count of trailing zeros. Given two integers representing the numerator and denominator of a fraction, return the fraction in string format. If the fractional part is repeating, enclose the repeating part in parentheses. To solve this problem, you need to handle both the integer part and the fractional, decimal, part of a division, especially when the fractional part has repeating cycles. Here's a breakdown of the algorithm and its implementation in both JavaScript and Python. Steps for the algorithm. Handle edge cases. If the denominator is 0, handle it according to your requirements. In most cases, this is an error. If the numerator is 0, return 0 as the result. Handle signs. Determine the sign of the result based on the signs of the numerator and denominator. If they have different signs, the result should be negative. Integer part. Perform integer division, for example, numerator/denominator, to get the integer part of the result. Fractional part. If there's no remainder after integer division, return the integer part as the result. If there is a remainder, calculate the decimal part. Use a hash map, or dictionary, to track remainders as you calculate each decimal digit. If a remainder repeats, that means the decimal part is repeating. Use the position where you first saw the remainder to identify the start of the repeating sequence. Format the result. Construct the final result string with parentheses around any repeating part. To find the nth natural number after removing all numbers that contain the digit 9, you need to skip all numbers that have a 9 in any digit place. Here's how you can achieve this. Understand the problem. We want to exclude any number containing the digit 9. This implies that for every natural number, you must check if the number contains the digit 9 and skip it if so. Conversion to base 9 representation. Instead of iterating over numbers and checking each for the presence of the digit 9, we can take advantage of the fact that when excluding all numbers containing the digit 9, the remaining numbers form a sequence analogous to the base 9 numeral system. We convert n into its corresponding base 9 representation and interpret it as a decimal number. This way, we skip all numbers containing the digit 9 in a single step. Steps to implement. Convert the given number n into a base 9 representation. Interpret this base 9 number as a regular decimal number to get the desired nth natural number. To solve the problem of finding the smallest positive integer value that cannot be represented as the sum of elements of any subset of a given array of positive numbers, we can use a greedy algorithm. Here's an explanation of the algorithm and its implementation in both JavaScript and Python. Algorithm explanation. 1. Sort the array. Sort the array in ascending order. Sorting helps us efficiently track the smallest sum that cannot be represented. 2. Iterate through the array. Initialize a variable smallest to 1. Representing the smallest number that cannot be represented so far. Check representability for each element in the array. If the element is greater than smallest, we cannot form smallest as a sum of elements in the array. Return smallest. Otherwise, add the current element to smallest to extend the range of representable sums pos4. Return smallest. If all elements are processed and no gap is found, return the final value of smallest.